Chapter 5. Can you believe you're already on Chapter 5? It's not even November. Chapter 5, Lesson 1. This is Part 1 of 2. Graphing linear equations and functions. Don't worry too much right now about the difference. Most linear equations are functions. Not all of them, but most of them. Okay, except when it's a vertical line. So for the most part, those are just terms that we'll talk more about later, and for the most part, they overlap. They're really pretty similar. You should have a piece of graph paper handy, a pencil, and a straight edge. Some sort of short ruler will be good. If you don't have those things, turn the video on to pause and go grab them. First thing, whether you write this down or not on your paper is up to you. It just depends how much you remember about this terminology about the coordinate plane. The middle is called the origin. Wow, it's spelled wrong here too. The person who made this, which wasn't actually me for part of it, seemed not to know how to spell the word origin. There, we'll fix it. And so make sure you know that that's this where 0, 0 is. It's not always, excuse me, at the middle of the graph. Depends how, kind of how you set your graph up, but it is always at 0, 0. And then we start in quadrant 1. That's where everything's positive in the upper right. And then when we go to number the rest, we go around counterclockwise. So quadrant 2, and then we come down bottom left for quadrant 3, and bottom right corner for quadrant 4. And we always use Roman numerals for those. We're looking today really at graphing equations in basically the same manner that you did last year, in Chapter 7 last year. So it's really just a review today of those ideas. If you want to find solutions to a linear equation in two variables, you need to find an ordered pair that when you plug the x and the y into the equation, it works. It's true. I'm thinking you can probably figure out some x's and y's that would work here. Right? Like if x was 2, y would have to be 3. If x was 4, y would have to be 2. Right? That's the input and the output. But it's a lot easier to graph these when equations are solved for y instead of what this form is, which is called standard form. When x and y are on the same side, it's called standard form. And when x and y are split up and they're solved for y, okay, then usually we call it actually slope-intercept form. We'll get to that later. You don't really need to write anything down from this slide. Those of you who've been frantically trying to write things down, if you didn't get anything written down, that's okay. I'll try to be really specific about what I want you to write down. I do want you definitely to write this part down. Steps to finding the ordered pairs. Step 1, get the equation solved for y. It is a lot easier to do it this way because then you don't have to solve for y every single time when you're plugging in values for x. We're always going to plug in values for x and then get values for y because x is our domain. It's our input values. To solve for x, this goes back to what we did way back, I think it was the end of Chapter 2, where we're solving for a variable. Write the equation down. We're trying to get y all by itself. The first thing that's in our way here isn't really this 2 that's multiplied by the y, it's this x. So we want to take x away from each side. And that leaves us then with 2y equals, and I'm actually going to reverse it, negative x plus 8. And it doesn't make sense probably to you right now, but as we get further on into this chapter, you're going to want to have the x first. So let's just start doing it now. And then we're going to divide everything by 2 to get rid of it. And you can leave it this way. Later on in the chapter, we actually will end up writing it so it looks more like this. Negative x over 2 plus 8 over 2. Oh wait, 8 over 2, that's just 4. Either of those would be fine. Negative x plus 8 all over 2, or y equals negative x over 2 plus 4. So once we've got our equation solved for y, then we're going to use the fave 5, negative 2, negative 1, 0, 1, and 2. For x, we always want to use at least some negatives and some positives. Sometimes you might have a good reason not to use those fave 5, but a different set of numbers. And this problem actually is a good example for when we might want to use something slightly different, because clearly even numbers are going to be easier than odd numbers, because you're dividing by 2. So let's actually not use the fave 5. Let's use the even fave 5. It's just going to fit here. We're going to make a table, and we're going to plug in our values, and we're going to crunch out the answer. So negative 4 plugged in for negative x. Ooh, that's going to be positive 4 over 2 makes 2, plus 4 makes 6. I might have lost a few of you there, so let's do it over here. Negative of negative 4 over 2 plus 4, right, is really 4 over 2, which is 2, plus 4 makes 6. If you prefer to do it from the earlier equation, you still get, then you get 12 plus, or 12 over 2 equals 6 also. Let's plug in negative 2 next. We get 2 over 2 is 1, plus 4 makes 5. 0 plugged in, we just get 4. Oh look, 6, 5, 4. I bet I could use patterns to figure out that this is going to be 3. Right, because I get negative 2 over 2 makes negative 1, plus 4 is 3, and then when I plug in 4, I get 2. I'm out of space there at the bottom of my screen. Now that we have our data, we can graph it. You need to set up your coordinate plane. I'm going to talk you through it. If I go too fast, feel free to go ahead and pause the video. I have some nifty little line tools here. Let's see if this works. So we draw a nice vertical and draw a nice horizontal, and we put arrow tips on. Doesn't need to be enormous, just enough to fit your data. Oops, that's not a very good arrow. And you're going to label the x-axis, and you're going to label the y-axis. That's the basic setup. You do also need to tell me what you're going to count by. You can count by 1s, you can count by 2s, you can count by 5s. You should count by something that makes sense for your data. So let's go back and look at the data. The data was from negative 4 to positive 4 on the domain, and the range is from 2 to 6. So I think I'm just going to count by 1s. That seems reasonable for this set of data. You can show me then that you're going to count, how you're going to count, by either marking the first few in each direction. Now I have to get my pencil back to just be a pencil. Come on. It won't change. All right, now I have an arrow. Okay, now I can actually write again. So you can either mark the first few in each direction, or other people like to just mark every 5. Whichever you prefer is fine with me. But you have to show me somehow, right, how you're counting, and the counting has to be consistent. It can be different on the x-axis than it is on the y-axis, but if you're going to count by 2s on x, then both to the left of 0 and to the right of 0, you have to count by 2s. If you're going to count by 5s on the y, then you always have to count by 5s both above and below the x-axis. Now we're going to take our data and we're going to plot those points. This should be feeling really familiar from last year. So I remember that at negative 4, we were at 6. So 1, 2, 3, 4, 5, 6. Put a point there. At negative 2, we were at 5. At 0, it was 4. At 2, it was 3. And at 4, it was 2. My points are nice and obvious. And then the last step, remember you're writing down your steps also, not just doing it. So you should have written down set up the coordinate plane, plot the points. And then step 4 is to draw a line with a ruler. And I know you can't see me, but I am putting my yardstick up against the screen. Can you hear it clattering? And I've got it there. I'm holding it nice and straight. And now I'm drawing a line using my ruler. Notice it goes beyond the 2 farthest points. And then I'm going to put nice little arrow tips because it's not a segment. It keeps going and going and going forever. Now, you try. I think this is the right one. Let me double check. Okay, this is the right one. So you're going to start off. You're going to write the problem down, and then you're going to pause it and create your table. And go ahead and pause the video, do as much as you can, and then come back and see if you're right. Now that you're back with me, I'm going to step you through it. So I needed to get the 3 x's away from each side. So my equation is y equals negative 3x plus 5. I'm just going to use my fave 5 here. And I plug in negative 2 and I get 6 plus 5 makes 11. Negative 3 times 1 is 3 plus 5 makes 8. 0 plus 5 is obviously 5. 1, I get negative 3 plus 5 equals 2. And I plug in 2 and I get negative 6 plus 5 equals negative 1. So I'm ready to set up my graph. Right? I'm going to draw my coordinate plane, and I need to go from negative 2 to positive 2. So let's just get that set up here. And it would be better if I was using a ruler for this part too, but it's a little inconvenient for me on the screen to use a ruler all the time. And then I need to go from 1 up to 11. So I'm actually realizing, wow, it actually would be better if my line was lower, because I don't really need anything hardly below 0 at all. You don't have to make a square coordinate plane every time. Now I'm going to draw my line as nice and tall as I can. Label the x and y axes. Decide what I'm going to count by. I'm going to count by 1s again. I'm just going to label the 5s and 10s, so every 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. If you prefer just to number a few in each direction to show me what you're counting by, that's fine also. And I'm going to get another color pen just because it's easier to see that way. Negative 2, comma 11. Negative 1, comma 8. 0, comma 5. 1, comma 2. And 2, comma negative 1. Notice that my points are in a line. These are linear equations. They always make a line. Always, 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 all the time, they make a line. So now you can take your ruler and you can draw your line through them. And now it looks like, well, did I make a mistake? Maybe I did, right? Oh, I did, right? See, I can tell I made a mistake because it's not making a line. So we don't want those. Good catch, Miss Passavoy. Caught your own mistake. There's my ruler clattering against the board. And draw my line, put my arrow tips on, and I'm done.